In this video, we're going to practice counting the number of scenarios within a binomial experiment. So for these types of problems, we're going to use the choose function to calculate the number of scenarios where we have k successes in n trials. So for each one of these problems, we're going to have a value for k and a value for n. When we talk about our choose function, this tells us the number of possible ways that we can arrange these k successes in n trials. So the choose function looks pretty intimidating, but as we'll see, hopefully, as we get a little bit more practice with it, it'll become a little bit easier for us to use. The choose function looks like n factorial divided by k factorial times n minus k factorial. Now, this might be the first time that you're seeing this factorial, this exclamation mark, in a math class. And it looks maybe a little bit intimidating, a little bit scary, but a factorial is relatively simple to calculate. If I wanted to calculate, say, 5 factorial, you're going to take that starting number 5 in this case and multiply it by every number that is less than or equal to 5 until I get down to 1. I'm just going to stop at 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And you would multiply that out. In this case, we should end up with 120. If I wanted 3 factorial, that would simply be 3 times 2 times 1, or 6 right here. The one special case that I should mention here, we may see this pop up from time to time, but if I have 0 factorial is actually equal to 1. But we're just going to practice using this choose function and working with it. And if you're careful with how you write these problems out, they actually condense, and we should be able to cancel a lot of stuff, which will make our calculations much easier to work with. So when we have k equals 1 success, n is equal to 4. This problem is actually not terribly difficult to do by hand. What we're really doing is we're thinking about how can we arrange that 1 success in 4 trials. And you could actually list these out right here. So if I had S for success and F for failure, if I'm running 1, 2, 3, 4 trials, you could have success, failure, failure, failure. So maybe the first trial is a success, and the last 3 are failures. And we could kind of just arrange that in a number of different ways. Perhaps the first is a failure, but the second is a success, and the last 2 are failures. And really what I'm going to do is I'm going to slide that success along. So now the success happened in the third event, and then here in this case, it'll happen in the last. So in this case, I've got 1, 2, 3, 4 different outcomes that I can have. So I should end up with 4. I can actually check my answer for this particular problem. I should hopefully end up with 4 as my answer. So I'm going to take these values and I'm going to plug my value for k and n into the choose function, this n factorial over k factorial times n minus k. So let's do that. N factorial, that is 4 factorial divided by k factorial is 1 factorial times n minus k. That's going to be 4 minus 1 factorial. So real quick, we want to make sure we follow order of operations. Inside the parentheses, I need to subtract that first. I like to simplify this first. This is going to be 3 factorial. So just to write that out so that we have it in front of us, I'm going to start to write this out. Now, these numbers are relatively small. It's not terribly difficult to write all of them out. If our numbers were larger, as we'll see in just a couple minutes, I'm going to write it out until I start to see a pattern, and we'll talk about what that looks like. So 4 factorial would simply be 4 times 3 times 2 times 1. 1 factorial is just 1, so that's fine. And then 3 factorial is 3 times 2 times 1. And what I should notice is I should have a series of numbers that appears in both my numerator and my denominator. In this case, 3 times 2 times 1 and 3 times 2 times 1. And what happens here is because that number appears in both my numerator and my denominator, I can go ahead and cancel it out. So I can cancel these 3's because 3 divided by 3 is 1. I can cancel the 2's, and in this case, I can cancel the 1's. And all that I'm left with in this particular case is 4 over 1, which is 4 There's my answer, and that is exactly what we said. There were 4 distinct ways that I could arrange these that one success in 4 trials. So this one was not terribly difficult to do in either case. But you can start to imagine if you have larger values of n or k, things are going to get very tricky very quickly. So if I had 9 different trials, you could say, okay, success, success, and then the last 7 would be failures. And you're going to have to think about all of the different ways that you could arrange these. 1, 2, 3, 4, 5, 6, 7. That's one case, and I need to think about, okay, well, what if I have success, failure, success, failure, 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 and so on. It would become very tedious to work all of these out. So it's much, much easier for us to use this choose function here. So if k is 2, n is 9, let's write out the formula first. So the choose function says n factorial over k factorial times n minus k factorial. So if I go ahead and plug these values in, n factorial is 9 factorial over k is 2 factorial times n minus k. That's 9 minus 2 factorial. Let's do just a little bit of work here first. 9 minus 2, this is really 7 factorial. So I'm going to start to write this out. I look at my numerator and I see 9 factorial right here. So let's write that part out first. 9, oops, what do I have here? 9 times 8 times 7 times 6 times, and eventually you're going to say, yeah, this is a lot of numbers, I don't want to do it. I can use an ellipse or those little periods right there to denote, hey, I'm skipping some numbers, but we can sort of see the pattern that's going on here. 9 times 8 times 7 times 6 times 3 times 2 times 1. There's my numerator. In my denominator, 2 factorial, well, that's not too terribly difficult to do. We can just write that out as 2 times 1. And usually what's going to end up happening is one of the numbers in your denominator is going to be larger than the other. So in this case, 7 factorial is greater than 2 factorial. I'm going to try and cancel out the 7 factorial if I can. So if I look at 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But if I want to follow the same pattern that I did up here in my numerator, I'm going to write 7 times 6 times 3 times 2 times 1. I'm skipping a set of numbers here. But what I look at and I see, hey, 7 in my numerator, 7 in my denominator. Those two should cancel. 6 in my numerator, 6 in my denominator. Those two cancel. That 5, 4, 3, 2, 1, all of these numbers are going to end up canceling. So what am I left with? In my numerator, I just have 9 times 8, and in my denominator, I just have 2 times 1. So my numerator, I've got 9 times 8 over 2 times 1. So 9 times 8, I should end up with 72 divided by 2. I should end up with 36. So that's the total number of ways that I can arrange these 2 successes in 9 trials. I would have had to list 36 of these different outcomes every single time, and that's just a pain in the butt to do. It's not feasible for us to do for every single problem. Let's take a look at one more. For my last problem, I have k is equal to 4 and n is equal to 11. So I like to write the formula out first, just for the first few times, until we start to feel a little bit more comfortable with it. That looks like n factorial divided by k factorial times n minus k factorial. So n is 11, so this is 11 factorial divided by k factorial is 4 factorial times 11 minus 4 factorial. Subtracting 11 minus 4 first, that should give me 7 factorial. I'm going to just take a peek at the denominator, and I see 7 is bigger than 4, so I'm going to try and cancel out that 7. When I go to write out my numerator, that 11 factorial, I'm going to try and work my way at least to that 7. So 11 factorial would be 11 times 10 times 9 times 8 times 7 times 6 times 3, 2, 1. And in my denominator, all right, 4 factorial, we can write that out. That's not too difficult to do. 4 times 3 times 2 times 1. And then the 7 factorial. This is the part that I'm going to try and cancel. I see 7 times 6 times following the pattern from my numerator, 3 times 2 times 1. And again, I should have 7 in my numerator, 7 in my denominator. 6 in my numerator, 6 in my denominator. We cancel all these numbers out in the middle. 3, 2, 1. So I still have some multiplication to do, but it's a lot less than what I started with. So in my numerator, I have 11 times 10 times 9 times 8. And in my denominator, I have 4 times 3 times 2 times 1. So let's go ahead and work this out here. 11 times 10 times 9 times 8. I have 7,920 for my numerator. And in my denominator, 4 times 3 times 2 times 1 gives me 24. So 7,920 divided by 24, I should end up with, in this case, 330. So if I wanted to list all of those different situations where I can arrange, in this case, 4 successes in 11 trials, I would have had 300